Hello there, and welcome. Tonight, we're not looking up, we're looking down. Beneath your feet is a world of fire and stone, pressure and patience. A world that moves in slow surges and sudden snaps. Geology isn't just rocks, it's the memory of the planet itself. Volcanoes that whisper secrets before they roar. Mountains that used to be ocean floors. Crystals that grow in total darkness, layer by impossible layer, and fossils that hold echoes of creatures long vanished. This is the deep story of Earth told in folds, faults, and forgotten time. A story far older than any book, but written in stone. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Beneath the crust of the Earth, where sunlight never touches and pressure mounts like an invisible hand, lies a churning sea of molten rock. This is where volcanoes begin, not as mountains, but as whispers of heat rising through stone. Slowly, patiently, magma gathers. It waits in silence beneath the surface, pressing upward with the weight of millions of years behind it. When it finally finds a weakness, a fracture, a breath of space in the rigid shell of the Earth, it surges upward not in chaos, but in rhythm. A volcano is not merely destruction, it is release. The core of some volcanoes burns so hot it can rival the surface of the sun. Thousands of degrees in temperature, enough to melt stone, reshape landscapes, and give birth to entirely new landforms. This fire does not roar with noise. In its deepest chambers, it pulses in silence, like the planet's hidden heartbeat. It doesn't announce itself. It builds and builds and waits. And when it finally breaches the surface, the result is breathtaking, not just in scale, but in meaning. In that moment, the Earth is writing something new. Under the oceans, where the dark is complete and the pressure would crush a human body flat, volcanoes are even more active. Down there, along the mid-ocean ridges, vast underwater fault lines that stretch for tens of thousands of kilometers, volcanic activity never truly stops. It doesn't explode outward like on land. It oozes and hardens, slowly constructing mountains and ridges, building new seafloor one layer at a time. These underwater eruptions have created more land than any other force on Earth. The continents themselves are dwarfed by the volcanic mountain chains that lie hidden beneath the waves, and yet we rarely think of them. They continue, unseen, writing the foundation of the planet while we go about our days. On land, the drama of eruption is easier to witness. When lava emerges, it does not always move in a slow, steady crawl. Some types, like the superheated, low-viscosity lava, known as basaltic, can move faster than a human can run. It races down slopes, glowing like liquid metal, consuming everything in its path. Trees, buildings, cars, all are reduced to ash and silence. In these moments, there is nothing metaphorical about Earth's power. It is literal, immediate, and undeniable. The ground becomes fluid, the rules dissolve, and all you can do is watch as the ancient engine of the planet reshapes the surface once again. In the chaos of eruption, something strange sometimes appears in the ash-choked sky. Forked tendrils of light, silent and sudden, crackle through the smoke. Volcanic lightning. It forms when ash particles rub together in the plume, generating static electricity in the most unlikely of places. It's a storm within a storm, a flash of raw energy in a sky already torn apart. These bolts strike through the darkness like reminders of how little control we have, of how easily the familiar world can twist into something mythic. Photographs of volcanic lightning are mesmerizing. In person, they must feel like standing on the edge of a dream where the planet is waking up angry. And yet, from these same eruptions comes life. New land, new soil, new beginnings. Iceland, the island nation of glaciers and hot springs, would not exist without the crack in the Earth's crust that runs between two great tectonic plates. The mid-Atlantic ridge slices through the ocean floor, and in that place of separation, magma has poured out for millions of years, cooling in layers, lifting stone from the sea. The island rose not in a single moment, but in a long series of fire-born chapters. Even now, the land continues to grow. Volcanoes there are not a distant threat. They are neighbors, landforms that breathe, and sometimes they speak. The people who live near them have learned not to see them only as danger. They've seen the long view. Volcanic ash enriches the soil. Geothermal heat warms their homes. Steam vents hiss beside hiking trails. Craters fill with blue water, and the sky above can glow with auroras while the ground below rumbles with ancient purpose. It's a reminder that the most violent forces of nature are not only destructive, they are also creators. Over time, volcanoes form islands. Islands become homes. Homes become nations. And nations, like the planet itself, are shaped by slow power. Power that sleeps more often than it wakes. When it does rise, it changes the map. But when it sleeps, it still shapes us in the heat beneath our feet. The stories pass down through generations. The understanding that the ground is not as still as it seems. There is something humbling about living on a planet that breathes fire. Something strange about knowing the same material that threatens lives also sustains them. The same eruptions that once extinguished entire species gave rise to new ecosystems. Volcanic plains become lush forests. Lava fields host rare flowers that grow nowhere else. The line between destruction and renewal is not as wide as we imagine. Sometimes they are the same thing. So the next time you see a photograph of an eruption, a glowing river of lava crawling across a hillside, or a plume of ash towering into the atmosphere, remember what it took to get there. The centuries of pressure, the magma rising in silence, the fault lines and ridges and molten pulses waiting patiently for release. Volcanoes are not explosions, they are expressions of something deeper. This world is still forming itself, still shifting, rising and folding. And we, for a brief moment, are witnesses. Time, for the Earth, is not measured in minutes or hours, but in pressures, collisions, and transformations. It moves not with the ticking of a clock, but with the shifting of continents, the layering of stone, the slow rise of mountains that outlive entire civilizations. The story of deep time is written everywhere if you know how to read it. In the smallest crystals, in the widest canyons, in the quiet memory of rocks older than anything alive. Zircons are among the oldest messengers. Tiny, resilient crystals no wider than a strand of hair, yet capable of holding the memory of Earth's earliest days. Some zircons, found in ancient Australian rock, are over 4.4 billion years old, older than the moon, older than any fossil, older than most of the surface we walk on. They contain traces of uranium, and as that uranium decays, it turns into lead at a steady rate. This decay, like a secret metronome, allows scientists to measure the passage of unimaginable spans of time. When you hold a zircon, you're not just holding a mineral. You're holding the memory of a world still cooling from its formation, a planet before oceans, before continents, before life, a planet still becoming itself. The Earth keeps its history in layers, and one of the clearest windows into that deep story lies in the carved heart of the American Southwest. The Grand Canyon isn't just a breathtaking scar in the desert, it's a timeline in stone. The canyon walls are stacked with sedimentary rock, each layer a different chapter of Earth's past. At the top, younger formations only a few 100 million years old. But as you descend, the story darkens, hardens, deepens. At the bottom, near the Colorado River, lie the Vishnu schist and Zoroaster granite, ancient metamorphic rocks that date back nearly 2 billion years. That means when you stand at the rim and gaze down, you're looking across time itself. Layer by layer, erosion has peeled away the Earth's skin, revealing the bones beneath. These rocks once lay at the bottom of oceans, were buried under mountains, were pushed and folded, melted and reformed. And now they stand in silence, exposed to the open air once again. The canyon didn't form overnight. It wasn't a sudden event. It was the slow insistence of water over time, carving, wearing, deepening over 5 million years of constant motion. A river, winding its way through rock like thought through memory. And in doing so, it cut into the very structure of time. Earth's history isn't just long, it's punctuated. Not by minutes or hours, but by endings. Mass extinctions mark the boundaries between geologic eras. There have been at least 5 major ones. Events where the planet shifted in ways so drastic that life itself had to begin again. The end Permian extinction, around 252 million years ago, wiped out roughly 90% of marine species. The end Cretaceous, which brought down the dinosaurs, cleared the way for mammals to rise. These boundaries are not abstract. They're preserved in the rocks, layers suddenly rich in iridium, an element rare on Earth but common in asteroids, ash beds filled with shocked quartz and glass spherules, fossils that vanish abruptly from one layer to the next. In these thin seams, you can see where the world faltered, blinked, and changed course. Between these catastrophes, life evolves. Mountains rise, oceans advance and retreat. The continents themselves drift like slow ships across the mantle, gathering and splitting in cycles that span hundreds of millions of years. The Earth has seen the rise and fall of supercontinents, massive landmasses like Pangaea, which once unified almost all land before breaking apart. These movements shape not just geography, but climate, ocean currents, and life itself. And the mountains they leave behind are monuments to this motion. Mountains do not rise quickly. They are built by forces we rarely feel, by plates pushing into each other, by rock folding over rock, by the crust itself buckling upward under pressure. The Himalayas, home to Everest, are still rising today, pushed skyward by the collision of India into Asia. But even Everest, towering in immense gains, only a few millimeters each year. It will take millions more to become something new. And eventually, like all mountains, it will wear away. Gravity, ice, and wind will pull it down. Sediment will wash into rivers, settle into oceans, and someday, given enough pressure, form rock again. The stone of Everest may rise again in a future range, under a different sky, on a continent not yet imagined. This is the tempo of geology. Not the rush of weather or the fury of a storm, but a quiet, relentless shaping that never stops, a rhythm we cannot hear unless we slow down. Unless we look beyond human time and into the deeper clocks the planet keeps. Even now, the Earth is changing. Somewhere, a new zircon is forming. A river is cutting into stone. A tectonic plate is shifting silently, setting the stage for a mountain range that won't fully rise for another 20 million years. And somewhere, perhaps beneath your feet, the rock carries stories older than life waiting, quietly, to be read. The ground beneath you is not still. It feels like it is solid, fixed, unmoving, but only because we live too briefly to notice its drift. If you could watch the Earth from far above, not for a day or a year, but for tens of millions of years, you would see the continents sway and scatter like slow ice on a dark ocean. Mountains would rise like waves, fold, then wear away. Oceans would vanish, swallowed by closing plates. New land would emerge where once there was sea. Everything changes, but on a scale so vast, it becomes invisible to the moment we inhabit. Continents move, not by inches in a day or miles in a year, but by millimeters over decades, about as fast as your fingernails grow. That is the pace of the tectonic dance, slow enough to feel eternal, fast enough to reshape the world. You are walking across a massive raft of rock, floating on a semi-liquid mantle, part of a jigsaw puzzle that is never fully solved. These plates, the great slabs of the lithosphere, push against each other, pull apart, and slip sideways. They crack, they grind, they dive beneath one another, and with each motion, they build and break the face of the planet. You can see the collision in the Himalayas. When India slammed into Asia, it didn't stop, it still hasn't. That ancient impact, which began more than 50 million years ago, continues today. The Indian plate drives northward, crumpling the edge of the Eurasian plate and forcing rock upward. That pressure raises the Himalayas millimeter by millimeter, year by year. Mount Everest grows taller with each passing moment, even as wind carves its flanks and snow weighs it down. And this mountain, the tallest in the world, is not an endpoint. It's a snapshot in a longer process. Someday, the uplift will stop. Erosion will win. But not yet. To understand this movement, you have to look back, farther back than cities or kingdoms or the oldest pyramids. Around 335 million years ago, the Earth's landmasses were united in a supercontinent called Pangaea. It wasn't the first, and it won't be the last, but it was immense, a single, connected world wrapped by a global ocean. Deserts stretched for thousands of kilometers, mountain chains crossed its interior. Life moved freely across what are now separate continents, but Pangaea too was only temporary. Around 200 million years ago, it began to break apart. Rifts opened, plates pulled away, water flowed into new gaps, creating seas that would become oceans. The Atlantic widened, fragments drifted North America, South America, Africa, Eurasia, Antarctica, Australia, each on its own slow journey through time. They are still moving today, circling the globe like quiet, stubborn dancers, and one day, far in the future, they will meet again. A new supercontinent will rise from the wreckage of the old. This motion isn't smooth. It builds tension in the crust pressure that gathers, locks, resists. And when that pressure releases, the Earth shakes. Earthquakes are not random. They are the voice of tectonic movement, the audible snap of plates under stress. The ground splits or slides or lifts. Shock waves ripple outward through rock and soil. Cities tremble. Oceans draw back and return in crashing waves. The power unleashed in a major earthquake can exceed the energy of thousands of nuclear bombs, but it comes not from fire or combustion, it comes from movement long delayed. A sudden correction after centuries of stillness. We feel the result, but rarely the cause. Fault lines mark where plates meet boundaries of collision, separation, or shear. Along the San Andreas Fault in California, the Pacific Plate slides past the North American Plate. It's a horizontal motion, grinding rock against rock with slow violence. The movement is measured in centimeters each year, but the release comes in seconds. In Japan, the Pacific Plate dives beneath the Eurasian Plate, creating deep subduction zones where megathrust quakes begin. These are the places where the Earth builds pressure like a bowstring pulled tight, and when it lets go, the result can shift coastlines, lift seafloors, and alter the spin of the entire planet. Yet even as earthquakes disrupt, they also build. The pressure that causes them uplifts mountains, opens rift valleys, forms basins, and reshapes landscapes. What feels like chaos in the moment is structure in the long view. The Earth doesn't make mistakes. It moves according to principles we've only just begun to understand. Beneath the crust, the mantle flows not like water, but like softened rock. It convects, rising and falling in slow loops that drag the plates above. That motion drives everything. It is the engine behind volcanoes, mountain chains, ocean ridges, and earthquakes. The quiet churn below that powers the drama above. and still, we walk across it without feeling it move. We build homes, plant trees, raise families on land that is always drifting. We draw maps as if coastlines are permanent, as if continents stay put. But the evidence is everywhere, in matching fossils on opposite sides of oceans, in mountain ranges that line up across continents, in the jagged scars of mid-ocean ridges hidden beneath the sea. The world we know is temporary, beautiful, solid, but temporary. In a few 100 million years, the Atlantic may close again. The Pacific might disappear. A new supercontinent, Pangaea Proxima, perhaps could gather Earth's scattered pieces into a single mass once more. It will feel as timeless to those who walk its forests and deserts as this world feels to us now. But it too will be fleeting. Plate tectonics is not just geology. It's a kind of memory, a record of the planet's ongoing transformation. And every quake, every ridge, every shifting grain of sand is part of that memory, moving quietly beneath us, one slow breath at a time. The ground does not speak often, but when it does, the sound can travel through the entire body of the Earth. A deep, low-frequency hum that pulses through the mantle and echoes around the globe. Some earthquakes strike with such force that the entire planet vibrates, ringing like a bell struck by a giant hand. The tremor may last for only moments at the surface, but the waves it sends ripple through the core, bouncing off boundaries, refracting and bending, measurable even hours later by instruments half a world away. The Earth, usually so silent, carries these vibrations like a memory it can't quite let go. We tend to think of earthquakes as sudden and chaotic, surprising moments that come from nowhere. But to the Earth, they are not sudden at all. They are the inevitable release of tension, the final breath after a long, silent inhale. Tectonic plates grind and catch, holding fast for years, decades, even centuries. Pressure builds beneath our feet, invisible and patient, until it finds a weak point and slips. In that moment, the built-up stress is unleashed as kinetic energy. The crust lurches, roads crack, water sloshes from harbors, and buildings, designed for stillness, sway as though the ground has turned to water. Not all earthquakes are the same. Some strike with violent abruptness. Others are slow, creeping ruptures moving so gradually over days or weeks that no human feels them, though instruments do. And then there are the deep earthquakes, ones that begin not in the brittle outer crust but hundreds of kilometers below, in zones where pressure and heat twist rock into strange, elastic behavior. These quakes confuse scientists. They defy the familiar rules of shallow tectonic motion, but they happen, and they remind us how much of our own planet remains unfamiliar. In some places, the Earth holds its breath more tightly than others. The San Andreas Fault, running through California, is one of the most studied and feared fault lines in the world. A boundary between the Pacific and North American plates, it stretches for hundreds of miles, a visible scar on the landscape. The plates on either side are locked in a slow, grinding argument. Tension gathers year by year, inch by inch, in the rock beneath. Scientists know this fault is a ticking clock, and though no one can say exactly when it will strike, it will. It always has. The silence, in this case, is the warning. And yet, while we may be caught off guard, others may not be. Throughout history, stories have been told of animals acting strangely before earthquakes, dogs howling, birds taking flight, snakes emerging from the ground minutes before the shaking begins. In laboratories and controlled studies, the evidence remains inconclusive. But in the field, again and again, people have observed these patterns. Perhaps animals hear the subtle groan of rock under pressure, or feel the tiny foreshocks that pass unnoticed by human senses. Whatever the cause, it's a mystery that hints at sensitivities we've lost or never had. The human connection to earthquakes isn't only as observers. We've become participants too. In recent decades, a surprising and sobering truth has emerged. Not all quakes are natural. Some are triggered by us. The injection of wastewater deep underground during oil and gas extraction has been linked to increased seismic activity in places that were once quiet. Mining operations and dam constructions can alter the stress balances in bedrock. Even filling large reservoirs has, in rare cases, caused the crust to shift. These are known as induced earthquakes, shakes born not of plate movement, but of human intervention. They remind us that the Earth is not an indifferent stage. It responds, and sometimes it pushes back. After a major earthquake, the surface may look the same. Trees still stand, buildings may survive. But the crust beneath has changed. A fault has slipped. A new alignment has been etched into the rock. Aftershocks continue, sometimes for weeks. The ground needs time to resettle. Seismometers record these motions, mapping their depth, their angle, their energy. These readings help scientists trace the anatomy of the event, how deep it started, how far it spread, what kind of fault it was. And from those traces, they begin to understand not just what happened, but what may come next. For all their devastation, earthquakes have given us insight into the hidden interior of our planet. By studying how seismic waves move through the Earth, geologists have mapped the layers of the crust, mantle, and core. The waves bend, slow down, or speed up depending on what they pass, through liquid, solid, dense, or fractured. That data allows us to build an image of a planet we can never touch directly. It's like using echoes in a cave to understand the shape of the walls. In this way, every earthquake becomes a kind of accidental sonar, a chance to glimpse what lies beneath. There is a stillness after a quake that feels unnatural. The birds are quiet. People speak in low tones. The ground itself seems to exhale. In those moments, the earth feels less like a backdrop and more like a living presence. Not hostile, not cruel, just immensely old, immensely powerful, and still shifting beneath our feet. It does not move on our schedule. It does not explain itself. But every so often, it reminds us that we are guests here. The crust we stand on is not solid in the way we think it is. It bends. It holds tension. It remembers. And sometimes, it speaks. Some rocks are not what they seem. We think of them as solid, inert, unchanging, silent witnesses to time. But some stones surprise us. They shimmer when they shouldn't, form in impossible shapes, or hold secrets buried for millions of years. These are the rocks that defy belief, the ones that seem, at first glance, like they belong in a dream rather than in the ground beneath our feet. Take opals, for instance. They don't sparkle like diamonds or refract like sapphires. Instead, they glow from within, catching light and scattering it in a kaleidoscope of blues, greens, oranges, and violets. That glow isn't from a pigment or a crystal lattice, it's from water. Trapped between layers of silica, millions of tiny spheres stacked in precise, microscopic grids. These layers bend light into different wavelengths, producing the shifting fire within. And in some opals, that water, the same moisture that makes them dance with color, has been held inside for tens of millions of years. Fossilized rain, captured beneath the earth and frozen in stone. When you hold an opal in your hand, you're cradling ancient weather. Yet it's not just their beauty that fascinates, it's their fragility. An opal can fracture with the change of a room's humidity. It can shatter if it's exposed to heat too quickly. It holds the memory of water, but it's always on the edge of losing it. In that way, it's not just a gem, it's a kind of clock, one that ticks without sound, counting down through time with every breath of air. Elsewhere in the world, stones form in shapes so smooth and round they look sculpted, but they aren't the work of tools or hands. They're called concretions, natural spheres or ovals formed when minerals precipitate around a core, like a pearl forming inside a shell. Over time, these minerals cement sediments together in ways that resist erosion, leaving behind perfect orbs scattered across desert floors or embedded in cliffsides. Some are as small as marbles. Others are larger than a person. They seem too deliberate, too consistent to be the result of randomness. But they are. These are the stones the earth made in silence, slowly rolling themselves into shape within beds of mud, never once needing a chisel. In the badlands of North Dakota and the shores of New Zealand, fields of these spherical rocks lie exposed, like forgotten game pieces from a long-lost giant. You can crack one open, and sometimes find a fossil at its heart, a shell, a leaf, a seed, as if the earth were trying to preserve not just the shape of things, but their stories. Then there are the geodes, ordinary on the outside, often dull and gray. You might pass one by, mistaking it for just another river stone, but inside, they're galaxies. Hollow chambers lined with crystals, amethyst, quartz, calcite, sprouting in every direction, frozen in the moment they bloomed. They begin as gas bubbles trapped in volcanic rock, pockets of emptiness left behind in a sea of cooling lava. Over time, mineral-rich water seeps in. Drip by drip, crystal by crystal, the hollow fills with growth, not quickly, not all at once, but over thousands or even millions of years. Cracking open a geode is like opening an egg from another world. The rough shell gives way to sparkling silence. It's hard not to feel something stir when you see those glittering interiors for the first time, hidden beauty that existed long before you arrived and would have remained hidden had you never looked. There's something profoundly patient about it. The idea that the earth can take a flaw, an empty space, and turn it into a sanctuary of light. And then, on the other end of the spectrum, are the stones that defy their very nature by floating. Pumice is a rock, but it drifts. Light enough to ride the surface of a lake, porous enough to hold air within its tangled matrix of hardened foam. It forms during explosive volcanic eruptions when magma is so frothy with gas that it cools into stone full of bubbles. These rocks are sometimes so buoyant they form floating islands, miles wide, drifting across the ocean like forgotten continents. Entire rafts of pumice carrying seeds, barnacles, even small creatures, ferrying life from one shore to another. You could hold a piece of pumice and not believe it came from fire. It's cool to the touch, dry, almost fragile, and yet it was born in an eruption, launched into the air, cooled mid-flight, and dropped into the sea. It is a contradiction stone that behaves like wood, fire that leaves behind something that floats. All of these rocks challenge the stories we tell ourselves about solidity. They prove that Earth is not always what it appears, that even the hardest things can be soft, that even the dullest stones can hold galaxies, and that what floats may once have burned. To walk through a canyon or along a shoreline and find one of these impossible stones is to stumble upon a kind of quiet magic. Not the kind spun from myth, but the kind that comes from pressure, time, and patience. The kind that reminds you the planet has been busy, all this time, shaping and reshaping itself in ways that feel, at times, like art. They're reminders, these stones, that the world is deeper than it looks. That beauty doesn't need to be loud. That even the Earth's slowest processes can produce something that makes you stop, look closer, and wonder how such a thing could possibly be real. Beneath the surface of the Earth, rocks carry memories not of sight or sound, but of direction. Magnetic whispers locked in stone, pointing not north or south as we know them now, but toward poles that once stood in entirely different places. This hidden memory is not something you can see with the eye or feel with your hand, but it's there, quietly embedded in cooled lava flows, ancient seabeds, and layers of hardened sediment. Like a forgotten journal, the planet's rocks have recorded the restless wanderings of Earth's magnetic field for billions of years. Every grain of iron-bearing mineral inside a rock has the ability to act like a microscopic compass needle. When lava erupts and begins to cool, These tiny minerals align themselves with the magnetic field present at that moment. As the molten stone hardens, this alignment is locked into place, frozen forever in the direction the field was pointing. These are not vague impressions, they are precise, measurable orientations, preserved even as continents shift and climates change. And when scientists examine these rocks today, they find a world where magnetic north was not always where we expect it to be. In fact, Earth's magnetic field has flipped many times throughout its history, not gradually, but abruptly, at least in geologic terms. North becomes south, south becomes north. The compass needle reverses, and the field itself weakens, fragments, and reforms in a new orientation. These events are known as geomagnetic reversals, and they've happened hundreds of times, sometimes separated by millions of years, other times occurring more frequently. The last major flip took place roughly 780,000 years ago, an event known as the Brunhes-Matuyama reversal. Before that, the field had been pointing more or less the opposite direction for nearly 1 million years. If you were to hold a compass during that time, it would have pointed south, not north, and no one would have found that strange. The process behind these flips lies deep within the planet's core. Earth's magnetic field is generated by the movement of molten iron within the outer core, a swirling, convecting ocean of metal, spinning in complex patterns. This movement acts like a dynamo, creating a magnetic shield that stretches far beyond the atmosphere, protecting the surface from cosmic radiation and solar wind. But the flow of molten metal is not always stable. It shifts, it churns, and sometimes that motion becomes chaotic enough to trigger a reversal. For a long time, it was thought these reversals might be catastrophic, interrupting life, disrupting climate, perhaps even causing mass extinctions. But the geologic record tells a more nuanced story. Life has endured every reversal so far. The field weakens during a flip, making the planet more vulnerable to charged particles from space. But the transition is survivable. What's more remarkable is how clearly these events are written into stone. Volcanic rocks are among the most reliable storytellers. When lava pours out during an eruption and begins to cool, the iron-bearing minerals inside it align with the direction of the magnetic field. Once solidified, these rocks become like frozen compasses, capturing the field's position at the exact moment of cooling. Scientists collect samples from lava flows of different ages and compare their magnetic orientations. What they find is a patchwork of directions, evidence that the magnetic poles have wandered, paused, flipped, and returned over and over again. Even ocean floor rocks carry these signals. As magma emerges along mid-ocean ridges and cools into new crust, it records the magnetic direction of its time. Over millions of years, as the seafloor spreads outward from the ridges, these rocks create a striped pattern of alternating polarity, like a barcode of Earth's magnetic history, stretching thousands of kilometers across the ocean basins. These patterns match perfectly on either side of the ridges, confirming the reality of seafloor spreading and the dynamic movement of tectonic plates. It was this very discovery, in the mid-20th century, that helped prove the theory of plate tectonics. If you could stand on a beach 100 million years ago with a compass in your hand, it might have spun slowly, confused, or pointed in a direction that today would seem entirely wrong. You would have no sense that anything was unusual. The sky would look the same. The waves would still rise and fall, but the field beneath your feet would be shifting, an invisible force, altering its shape, rewiring the planet's magnetic map. And even today, the magnetic field is not fixed. The North Magnetic Pole is drifting at a surprisingly rapid pace currently, moving from the Canadian Arctic toward Siberia at nearly 50 kilometers per year. No one fully understands why, though it likely reflects ongoing changes in the flow of molten iron within the core. It reminds us that this force we rely on for navigation, for protection, for orientation, is anything but static. It breathes, it pulses, it changes. In the grand expanse of geologic time, what seems stable is often the most deceptive. Mountains rise and fall, oceans open and close. Even the very concept of north can reverse. And through all of this, rocks remember. They hold on to direction long after the field has moved on. They preserve the invisible. They make tangible the movements of fire and metal that shape the deep heart of the planet. Every stone with magnetic memory is a fragment of the Earth's shifting mind. And when we study them, when we listen to what they quietly reveal, we glimpse a world in flux, a planet not frozen in place, but endlessly turning itself inside out, writing its story in fields we cannot see, and capturing that story forever in the hardened breath of cooling stone. Inside, every crystal is a lesson in patience, a stillness that shapes itself, not in days or years, but across eons, in silence and darkness. Minerals do not hurry, they do not guess. They follow rules written by the laws of chemistry, pressure, and heat. And in that obedience, they build geometry more precise than anything we can draw by hand. Perfect angles, clean lines, repeating forms that echo throughout their structure. Every face, every edge, is a frozen moment of atomic order. Quartz is one of the most abundant minerals on Earth, and yet there is nothing ordinary about it. Clear, milky, smoky, or tinged with amethyst's violet hue, quartz is more than just beautiful. It is rhythmic. Each crystal vibrates at a steady frequency, determined by its shape and size. This quality is so consistent, so dependable, that we've built our timekeeping around it. Quartz oscillators power the watches on our wrists, the clocks on our walls, even some of the processors inside our computers, ticking not with gears or springs, but with vibrations measured in the millions per second. A heartbeat you can't hear, but one that divides time into perfect intervals. This isn't magic, it's piezoelectricity. When pressure is applied to a quartz crystal, it generates an electrical charge, and when electricity is passed through it, it responds with motion vibrating in steady, microscopic pulses. This relationship between force and energy makes quartz both a tool and a teacher. It reminds us that even something as still as a stone can hum with invisible rhythm. But not all crystals are born in calmness. Some are forged in violence. Diamonds, for all their elegance, often begin in chaos. While many form deep in the mantle under pressure and heat, others arrive in flashes born not from volcanic calm, but from cosmic impact. When a meteorite slams into Earth with unimaginable force, the pressure at the point of contact becomes intense enough to rearrange the atoms in carbon-bearing rocks. In a heartbeat, graphite is crushed into diamond. These impact diamonds are small, scattered, and rarely perfect, but they exist tiny monuments to collisions that reshape the surface of the Earth in an instant. Gems made not by time, but by trauma. Elsewhere, crystals take their time and get creative. Bismuth, a heavy metal often overlooked, grows in fantastical shapes. As it cools from a molten state, it forms stair-stepped spirals, angular and geometric, like something carved by a mathematical hand. Its colors come not from pigments but from light interference. Thin layers of oxidation on the surface reflect light back in waves, creating iridescent sheens of pink, green, blue, and gold. Bismuth crystals look alien, like miniature cities or temples from a forgotten civilization. And yet, they can grow in a dish on a lab bench, slowly rising into structure as they cool. Nature is filled with these surprises, moments when beauty isn't added but emerges from the rules themselves. Crystals do not choose to be beautiful. They simply follow the paths laid out by their molecular geometry, assembling themselves atom by atom into forms that seem too perfect to have formed by accident, because they didn't. They followed the pattern written into their chemistry. Some minerals, hidden to the eye in daylight, come alive under ultraviolet light. They fluoresce, glowing bright, green, blue, orange, or red when exposed to wavelengths we can't usually see. This glow isn't a trick or an illusion. It's the result of electrons within the mineral absorbing energy and re-emitting it in visible form. The atoms within are excited by the UV, briefly pushed into a higher state, and as they settle back down, they release light. The result is a secret language, a glowing signature that reveals which elements are present and how they're arranged. Fluorescent minerals are scattered all over the world, tucked inside caves, embedded in cliffs, buried in mines. Under the right light, they transform from dull rocks into luminous sculptures. In some places, entire caves glow. You can walk into darkness and be greeted by a ceiling of green and violet stars, like a night sky turned inside out. And in those moments, it's hard not to feel that the planet is quietly showing off. But crystals are not just decorative, they are essential. Beneath their beauty lies utility. We use them to cut, to transmit signals, to focus energy. Salt is a crystal, so is snow. Even the bones in your body contain mineral crystals of calcium phosphate, structured to provide strength. Crystals grow in coral reefs, in hydrothermal vents, in meteorites that fall from space. They mark the passage of time inside geodes, growing inward year by year, like tree rings built from light and patience. In ancient times, crystals were thought to hold mystical properties, powers of healing, protection, and divination. And while science has stripped away much of that mythology, it has replaced it with something just as awe-inspiring: the understanding that crystals are born of order. They represent what happens when atoms arrange themselves in their most stable, most efficient forms. When energy finds balance, structure emerges. Every crystal tells a story of its environment: how hot it was, how much pressure it endured, how long it took to grow, and once formed, they endure. They outlast trees, bones, civilizations. They sit beneath the earth, waiting to be uncovered, not because they need to be seen, but because they simply are silent testaments to the structure of the world. And so, when you hold a crystal, you are not just holding something beautiful, you are holding a blueprint, a fragment of time shaped by mathematics and chemistry, by temperature and patience. Whether it came from deep underground, from a meteor's fiery crash, or from a slow drift through cooling water, it carries within it a message that even in chaos there is order, and even in silence there is a kind of music, the quiet geometry of nature playing itself out in stone. Fossils are the breathprints of vanished worlds, not just bones turned to stone, but echoes of movements, of stillness, of lives that flickered and vanished long before ours began. They are not simply objects buried in rock. They are the memories of ancient beings, preserved by accident and geology, whispered forward through time. A ripple in mud, a fallen leaf, a spiral shell pressed into sand, all caught in the act of being, then slowly encased by sediment, compressed by time, and transformed into something both silent and eternal. It doesn't always take millions of years. Fossils can begin forming in less than 10,000, sometimes even faster, under the right conditions. When a creature dies and is quickly buried beneath sediment by a river's flood, a volcanic ashfall, or a collapsing dune, the process begins. The soft parts decay, but the shape remains. Minerals seep in, grain by grain, atom by atom, replacing organic material with stone. Over time, the bones become rock, the outlines become maps, and the trace of life becomes a monument to it. It's not just preservation, it's transformation. There are places on Earth where entire forests have turned to stone. Petrified wood is not wood at all anymore. It's quartz, iron, manganese, and other minerals that have replaced every cell of the tree. But the structure remains, down to the grain and the bark. These trees, once swaying in ancient winds, now lie frozen beneath deserts, their roots tangled in rock, their branches reaching out not for sunlight, but for deep time. In the petrified forest of Arizona, trunks lie scattered like fallen giants, still bearing the rings that counted their years. Trees that grew in the late Triassic, when early dinosaurs walked among them, now sleep beneath a sky utterly changed. And yet, some fossils stretch further back than we can easily imagine. Before forests, before shells, before anything with legs or eyes, there was life simple, single-celled, floating in warm, shallow seas. Some of the oldest fossils on Earth are stromatolites, layered mounds of ancient microbial communities. These bacteria lived in colonies, building thin films of life that trapped sediment and grew slowly, layer upon layer, into rounded domes. In places like Western Australia, you can find these fossils over 3.5 billion years old. They are older than the moon as we know it, older than animals, older than plants. They are the architects of the oxygen we breathe today, and they are still here. Living forms of them still grow in some salty bays, still reaching skyward as they did before the first leaf ever unfurled. Fossils tell stories not just of individuals, but of the Earth's shifting face. On mountaintops, you can find the remains of trilobites, small, armored creatures that once scuttled across seafloors. Their presence high above sea level is not a mistake. It's a record, a testament to uplift, to tectonic forces pushing seafloors into the sky. The Himalayas hold marine fossils. So do the Alps. Rocks that once rested in deep ocean trenches now scrape the clouds, bearing the impressions of creatures long extinct. These are the travel logs of continents, the footprints of oceans that no longer exist. Trilobites themselves are among the most famous fossils, complex, beautiful, and incredibly varied. With compound eyes and segmented bodies, they were among the earliest animals to develop vision. Some had spines like thorns, others were smooth and sleek. They lived for over 270 million years, adapting to every ocean, and then, like so many others, vanished in a mass extinction. But they left behind a fossil record so rich and so detailed that we know their life stages, their molting patterns, even their predator-prey relationships. In stone, they tell of vibrant ecosystems, of shallow seas teeming with life, of ancient tides long forgotten. Sometimes, the fossils we find are of creatures we never expected. Soft-bodied animals that, under rare circumstances, left imprints so delicate they capture the fine hairs of a wing or the shape of a jellyfish. These exceptional fossils require perfect timing and conditions, low oxygen, rapid burial, still waters, but when they form, they give us not just bones, but behavior. We can see a fish caught mid-swim, a feather dropped from a dinosaur's flank, a beetle with its wing covers spread. These are fossils that breathe, that tell us not just what something was, but how it moved, what it might have felt like to see it alive. And then there are the trace, fossils, tracks, burrows, nests. Not the body, but the evidence of presence. A trail across mud that hardened into stone. A footprint filled in with silt, then compressed over millennia. These are the most human of fossils, in a way. They're not about death. They're about life in motion. An animal passing by, unaware that it was writing in a medium meant to last eons. To hold a fossil is to touch deep time, not metaphorically, but literally. The stone in your hand may have once been a ripple of flesh, a twist of bark, the curve of a fin. It may be a moment frozen from a world that no longer exists, recorded not in ink but in sediment and pressure. The earth does not forget easily. It writes its memories in stone, in layers that stack one upon another, each holding the breath of what came before. In this way, fossils are more than curiosities. They are the planet's way of remembering. They are its autobiography, written slowly, in a language we are just beginning to understand. Every fossil is a message from a world that was, a whisper from a body that moved, breathed, lived. And in those quiet whispers, we are reminded of how brief our moment is and how deeply it is connected to everything that came before. Beneath the ground, where sunlight cannot reach and time flows in different shapes, the earth builds its most secret architecture. Caves are not just hollow spaces carved by water and darkness. They are temples sculpted in slow motion, formed drop by drop, crystal by crystal, over spans of time that far exceed memory. To enter a cave is to step into a world where every surface whispers of patience. Here, the ceiling is alive with teeth of stone. The floor rises in frozen drips. Air moves differently. Sounds echo longer. And the silence is so complete it feels like a presence. Some of these underground chambers are vast enough to feel like dreams. In the Son Dong Cave of Vietnam, the largest known cave on Earth, you can walk through tunnels that could swallow skyscrapers. A Boeing 747 could fit inside with room to spare. But this is not an empty space. It is a world unto itself. Son Dong has Palo, its own weather systems. Mist gathers and floats through the chambers like breath. Light filters through collapsed ceilings, illuminating jungles that have taken root on the cave floor. Trees grow inside. Insects and animals that live nowhere else skitter through the shadows. It is a pocket of earth untouched for millions of years, sealed away and growing quietly in the dark. Elsewhere, caves become crystal cathedrals. In Mexico, deep below the surface, the Cave of the Crystals holds selenite formations longer than buses and thicker than tree trunks. These gypsum crystals grew over hundreds of thousands of years, undisturbed in chambers so hot and humid that human explorers can barely survive inside without protective suits. The crystals themselves are impossibly clear, as if sculpted from glass, and they stretch across the space in impossible directions, vertical, horizontal, spiraling through the air like frozen lightning. Walking among them feels like moving through the skeleton of another world. But even in smaller caves, there is wonder. Stalactites hang from the ceiling, slow-growing spears of calcite formed as mineral-rich water drips through cracks in the stone above. Every drop deposits a minuscule amount of calcium carbonate, and over decades, centuries, millennia, those deposits become pillars. A single inch of growth can take 100 years. And yet they grow, never stopping, never rushing. Stalagmites rise from the ground in answer, formed by the same patient process. And sometimes, after tens of thousands of years, the two meet in the middle to become a column, a bridge of stone, joining floor to ceiling, like a tree that grew upside down. In the quiet of these spaces, sound takes on strange shapes. Caves are natural resonators, amplifying whispers and footsteps, turning even a sigh into something cathedral-like. Some formations sing when touched. Tapping on thin stalactites can produce bell-like tones, each one ringing with its own frequency. These lithophones are not new discoveries. Ancient people used them in ceremonies, drawn to the otherworldly sounds that only the earth itself could make. The cave sings, not with voice, but with vibration, humming in frequencies shaped by the stone's density, length, and history. And in that darkness, the absence of light becomes its own kind of canvas. Bioluminescent fungi sometimes glow on the walls. In New Zealand, glowworms dangle from ceilings, casting a soft blue-green light like stars in a night sky flipped upside down. Their glow is a lure, designed to draw in prey, but for those who witness it, the effect is hauntingly beautiful. You find yourself floating through darkness that feels infinite, guided only by lights that never move. Some caves hold traces of the earliest humans, paintings, carvings, soot from ancient fires. The walls become libraries of forgotten dreams. Red ochre bison run across limestone, handprints press into stone like echoes of touch. These are not just decorations. They are proof that even tens of thousands of years ago, humans looked into the dark and saw stories. And yet, caves are not merely still. They are living landscapes, changing with every drop of water. Minerals dissolve, then reappear. Caverns collapse. New passages open. A single shift in groundwater can reroute centuries of growth. To the untrained eye, nothing may seem to move. But in the geologic scale, caves are constantly rewriting their architecture in slow motion. To step into a cave is to cross into a place where human time loses its grip. Your footsteps fall softer, your voice echoes longer. You become a visitor in a world that has no need for clocks. The walls have watched ages pass without light, without wind, without the touch of sun or storm. And yet they grow, not in haste, but in certainty. You might never notice a stalactite change, even if you stood beneath it for a lifetime. But the cave remembers. It marks time not in hours, but in crystal. In each ring of calcite, in each layer of sediment, there is the slow heartbeat of the planet. It is here that the earth reveals its capacity for stillness and its endless creativity, not through eruption or quake, but through a drop of water and the way it leaves behind a tiny, gleaming trace. In these underground cathedrals, we are reminded of something simple and profound. Beauty doesn't need light. Growth doesn't need speed. And silence, when listened to deeply enough, can carry the voice of the earth itself. Every night, above the hush of sleeping cities and quiet forests, small stones from the heavens slip through the sky. Some flare and vanish in the blink of an eye, burning out before they touch the ground. Others make it all the way. Meteorites, fragments of cosmic debris, fall to Earth every day, uninvited but not unnoticed. Most are tiny, smaller than pebbles, but once in a while, one arrives that reshapes the planet's story. They are not just rocks, they are messages from the void, carrying with them the history of stars, planets, and time before time. The Earth is struck by meteoritic material constantly. Tens of thousands of tons of space dust settle on the planet each year, invisible and silent, coating mountaintops and ocean surfaces with the fine ash of the cosmos. These specks may not seem like much, but every now and then, something larger breaks through. A piece of asteroid or comet, traveling at tens of thousands of kilometers per hour, punches through the atmosphere. The sky lights up. A sonic boom cracks the air. And then, sometimes, a crater is left behind a wound in the surface where the sky met the ground. Some meteorites are older than Earth itself. The oldest known one, found in the Sahara, dates back more than 4.5 billion years older even than the Sun. Known as the Erg-Chech 002 meteorite, it is a fragment of a protoplanet that once tried to form during the earliest days of the solar system, then failed, shattered, and drifted. For billions of years, it tumbled through space, untouched, unchanged, until gravity brought it here. To hold it is to cradle a time before planets, before oceans, before anything we know as familiar. And not all meteorites are anonymous. Some are lunar. Pieces of the moon, blasted away by ancient impacts, have made their way to Earth. These rocks, ejected from the lunar surface by collisions, floated through the void for millennia until they landed in deserts or on Antarctic ice. They look ordinary, dull, dark, unassuming, until scientists recognize their mineral fingerprints. The composition is unmistakably lunar. In this way, it's possible, without ever leaving the Earth, to hold a piece of another world in your hands. Similarly, there are Martian meteorites too. Inside some of them, under microscopes, scientists have found structures that stir debate. Could they be traces of ancient Martian microbes or merely geology mimicking biology? The answers are still unfolding, but perhaps no meteorite changed Earth more than the one that fell 66 million years ago. The Chicxulub impactor, named after the region in Mexico, where its crater now lies buried, was roughly the size of a mountain, moving at 20 times the speed of a bullet. When it struck, the energy released was beyond comprehension. Forests thousands of kilometers away burst into flame. A tsunami taller than buildings raced across oceans. The atmosphere filled with pulverized rock and sulfuric acid, blocking the sun. Temperatures dropped. photosynthesis halted, food chains collapsed, and with chilling speed, 75% of all life on Earth vanished. Among the lost were the non-avian dinosaurs, whose era ended not with a slow decline, but with a single, catastrophic event. The crater itself, more than 150 kilometers wide and buried beneath layers of sediment, was only confirmed in recent decades. But its story was always written in the fossil record, a sudden, sharp line where diverse species disappear and only the adaptable or fortunate survive. From that extinction came the rise of mammals, and eventually, us. Without that meteorite, there might never have been humans to tell the tale. Meteorites connect us not just to the past, but to the immensity beyond. Their composition is alien, rich in rare metals, pocked by entry scars, sometimes carrying grains forged in the atmospheres of dying stars. These presolar grains are tiny microscopic diamonds or silicon carbide crystals, but their age defies imagination. They predate the Earth. They predate the Sun. They are dust from ancient supernovae, drifting for billions of years before becoming trapped in a meteorite that finally landed here. They are time capsules from a universe in motion. Some fall in flashes of drama like the Chelyabinsk meteor in 2013, which exploded in the skies over Russia, shattering windows and shaking buildings with its shockwave. Others fall quietly, sinking into the sea, buried forever. Hunters search for them in deserts, where the contrast between black stone and pale sand reveals them. In Antarctica, the ice preserves them perfectly, their dark shapes standing out against the white. Finding one is like finding a letter addressed to Earth from the rest of the cosmos, and there's something deeply humbling about that. Because while we look to the stars for wonder, the stars sometimes send pieces of themselves to us. These fragments remind us that our planet is not sealed off. It is part of a larger story connected by gravity, by debris, by collisions, and chance. And while the Earth has been shaped from within by volcanoes and tectonics, it has also been shaped from without, sculpted by the stones that fall from sky to sea. To hold a meteorite is to touch what once drifted between planets. It is to feel, in the weight of your hand, something that may have circled the sun 1,000 times before it ever knew our skies. It is to be reminded that the universe is not elsewhere, it is here, brushing past our atmosphere each night, falling silently onto rooftops, fields, oceans, not rare, but constant. The Earth wears the scars of its encounters. Impact craters become lakes, become forests, become forgotten, but the memory lingers, in stone, in sediment, in the bones of vanished creatures. Each meteorite carries its own story, and when it lands, the sky becomes just a little more familiar, and the ground beneath our feet just a little more cosmic. Mountains have always felt eternal, still, immovable. They rise in the distance like frozen waves, casting long shadows across valleys and rivers, anchoring the horizon with their jagged silhouettes. To stand at their feet is to feel small, ancient, and impossibly young all at once. But even the tallest peaks are not as solid as they seem. Mountains move, they shift and buckle, and rise in silence. Their strength is real, but it's not the strength of permanence. It's the strength of slow change, of patience measured in millions of years, because every mountain you see is still on the move. Beneath your feet, the surface of the Earth drifts. Tectonic plates glide on the semi-molten rock below them, colliding, pulling apart, grinding past one another. When they meet head-on, the crust crumples like paper, folding into peaks. These folds grow higher with every tremor, every collision, every slow motion thrust from below. The Himalayas, the tallest mountains on Earth, are still rising today, driven upward as the Indian plate presses northward into Asia. They rise at about 1 centimeter per year, which doesn't sound like much. But over millions of years, it builds kingdoms of stone. And yet, height doesn't promise permanence. The taller the mountain, the more fiercely the planet tries to pull it back down. Rain carves into the slopes, wind shaves the ridges, ice cracks boulders open from within. Rivers carry away the dust and fragments, transporting them to the sea. This erosion happens constantly, day and night, regardless of whether anyone is watching. Mountains crumble even as they rise, and sometimes faster. The balance between growth and decay is delicate. A range can surge into the sky, only to wear down again into rolling hills and weathered ridgelines. The Appalachian Mountains in the eastern United States are proof of that long descent. Today, they are gentle and forested, worn down into soft curves. But long ago, more than 450 million years, they were taller than the Himalayas. Born of ancient collisions when supercontinents gathered and broke apart, they once pierced the sky with sharp peaks and towering walls of rock. Now, they wear their age like wrinkles in stone. And in that softness, there is quiet majesty, a beauty earned over hundreds of millions of years of wind and rain and time. Not all mountains are born from direct collision. Some rise from below. In places like Iceland and Hawaii, molten rock from deep within the mantle pushes upward, breaking through the crust and piling up into volcanic peaks. These islands are mountains too, built not by the crashing of plates, but by the Earth's interior reaching for the surface. Each eruption adds another layer. Each flow of lava is a new line in the story of that mountain's slow ascent. And there are mountains you cannot see. Under the oceans, far from sunlight and air, lies the Mid-Atlantic Ridge, a continuous mountain chain that snakes around the globe like a seam on a baseball. It stretches for more than 40,000 miles, longer than any range on land, but most of it remains hidden beneath miles of water. Here, tectonic plates are pulling apart, and new crust is rising to fill the gap. These submarine mountains are young and raw, still hot from their birth. They remind us that mountain building isn't confined to the places we can see. The earth reshapes itself in silence, whether or not we are there to watch. Even in the most stable-seeming ranges, the ground is never entirely still. Mountains store stress deep in their roots, stress from the pushing, twisting, folding of the crust. When that stress is released, it sends shivers through the earth, earthquakes, landslides, avalanches. These sudden events are moments of change, but the mountains themselves are always changing, even in the quiet. They lean, settle, fracture. Their shapes shift with the seasons. Snow builds on their peaks, melts into rivers, freezes again. With each freeze-thaw cycle, rocks split a little more. The mountain loosens a bit further, grain by grain, boulder by boulder. The creatures who live among mountains often adapt to this flux. Trees cling to slopes at impossible angles. Animals burrow into the soil or leap from ledge to ledge, sensitive to the vibrations of shifting ground. In some places, entire communities build their lives into the sides of cliffs, carving homes into stone, growing food on terraces. There's a kind of reverence in these settlements, a recognition that the mountain gives and takes in equal measure. To geologists, mountains are not static. They are waves, slow, frozen waves of rock that rise and fall over vast spans of time. And like ocean waves, their shapes are governed by forces both near and distant. The weight of glaciers, the angle of erosion, the drag of continents still drifting apart, all of these combine to sculpt the peaks. Some mountains erode into ranges of jagged spires, others into rounded domes. Some collapse into themselves, while others split open to reveal veins of mineral, crystal, or ancient fossil. When you hike a mountain trail, your feet are pressing into a surface that was once seafloor or magma or desert. The rock beneath you has been elsewhere, formed under different skies. It remembers heat and pressure, remembers being bent and buried and reborn. You are walking on stories older than the species that reads them. And even now, the mountain moves. Not fast enough to see, but fast enough to matter. In a few thousand years, the trail might shift. The summit may weather down. A new peak may rise beside it. The changes won't wait for you to notice. They continue, as they always have. The earth is never done building mountains, and never done letting them fall. The desert seems silent at first. A stillness stretches across the horizon, broken only by heat shimmering above the sand and wind that barely whispers. But if you listen closely, the desert is speaking. It does not shout, but it hums a low, eerie, resonant sound that rolls through the dunes like a distant song. This is no illusion. Some sand dunes sing. As their grains cascade down steep slopes in the dry air, they can vibrate together, creating a deep, musical drone that lingers and travels. Not all dunes do it. Only those with the right grain size, moisture, and shape can produce this chorus, but when they do, it's as if the land itself has become an instrument, playing a note that has been echoing through time. This sound isn't new. Ancient travelers wrote of it. Desert caravans once paused to listen to what they called the voices of the dunes, unsure whether they came from wind, jinn, or something stranger still. Today, we know the science behind it: grains rubbing, frequencies aligning, but the wonder remains untouched. To hear the desert sing is to be reminded that even in its apparent emptiness, the world is alive with unexpected expression. And just as dunes can sing, stones in the desert can move. In places like Death Valley's racetrack playa, rocks have been seen with long, curling trails behind them, evidence of movement, but no sign of what moved them. For decades, these sailing stones puzzled geologists and inspired quiet myths. Were they pushed by animals, pulled by magnetic fields, carried by trickster spirits? The answer came only recently, and even now feels like something out of a dream. On rare, cold nights, a thin layer of ice forms beneath the rocks. As the morning sun warms the surface, the ice begins to crack and shift. Wind catches the rocks atop these delicate sheets, and they slide, slowly and silently, carving winding paths into the mudflat. No hands, no wheels, just ice, wind, and time conspiring to move the unmovable. In the desert, time does not pass as it does elsewhere. It stretches and settles into stone. The wind carves endlessly, shaping even the hardest rock into curves and hollows, arches and spires. And in that carving, something delicate and rare appears, a dark, shiny coating on exposed surfaces known as desert varnish. It's a thin layer of manganese and iron oxides, bonded to the rock over thousands of years by microbes and dust. You'll see it on petroglyphs, where ancient peoples etched symbols into the dark surface to reveal the pale stone beneath. The varnish grows so slowly that you could wait a lifetime and never see it change. But it's there, slowly accumulating, darkening the stone like a polished memory. In some places, desert varnish is more than 10,000 years old, older than written language, older than agriculture, clinging quietly to the bones of the earth. Deserts often feel like the end of something, the place where life gives up, where rain never falls, where rivers vanish into sand. But deserts are not endings, they are transformations. Many deserts were once oceans, and their sands are the remnants of seabeds, pulverized coral, and long-lost waves. In the Sahara, whale fossils lie buried beneath the dunes, their bones curled in fossilized repose where once warm seas lapped at the shore. In Utah, the red sandstone cliffs that rise above the desert floor are made of ancient sand dunes, themselves petrified and stacked like pages in a book, each layer a chapter in a story written by wind. Deserts can also become oceans again. Climate shifts, tectonic changes, and long, slow cycles of Earth's breath can turn the dry into wet and the barren into fertile. Nothing on Earth stays as it is. Even the most inhospitable places are part of a longer rhythm, moving in and out of heat and water, silence and sound. What looks like stillness is often the pause between verses. In the midst of all this erosion, there's a strange kind of artistry. Wind-blown arches, hoodoos, and balanced rocks are not carved by hand, but by patience. Tiny grains of sand, lifted by the breeze, strike the rock with the soft insistence of time. Over centuries, this sandblasting sculpts patterns more intricate than any tool could manage. Nature does not rush. It does not hesitate. It simply continues, reshaping mountains into mesas, cliffs into columns, boulders into dust. At night, deserts reveal their truest character. With no moisture in the air and no clouds in the sky, the stars come closer. The silence becomes deeper, and the sand, having absorbed the heat of the sun all day, cools rapidly, as if exhaling. Creatures emerge nocturnal and quiet, leaving trails across the surface that will vanish by morning. The dunes shift slightly, not with drama, but with the soft insistence of wind. Erosion is not destruction. It's movement. It's change. It's the gradual reimagining of the world's surface by forces that don't seek permission or notice. In this way, deserts are not wastelands. They are galleries. Every ripple of sand, every polished stone, every singing dune is part of a story millions of years long, told not in words, but in shape and silence. And if you walk there slowly, gently, with the wind in your ears and the crunch of fine sand beneath your feet, you begin to feel it. The desert is not still. It only appears that way until you learn how to listen. Then, suddenly, you hear the hum, you see the motion, and you understand that even in the most barren places, the earth is always in the act of becoming. A single drop of water doesn't seem like much. It falls quietly, makes the softest sound, then disappears. But water has never needed force to shape the world, only patience. Let it fall often enough, in the same place, across days and centuries and epochs, and even granite yields. Stone, for all its hardness, is not immune to time, and water, persistent and unassuming, is its most faithful sculptor. A raindrop finds a crack in the rock and settles in. Cold nights freeze it, warm days melt it, and each cycle widens the space just slightly. Multiply that by 1,000 seasons, then 1,000,000. What begins as a line too fine to see becomes a fracture, then a channel, then a gorge. In places like the Grand Canyon, water's artistry is unmistakable. Miles of chiseled cliffs descending into shadow, layer upon layer of time removed grain by grain. But even the quiet trickle of a forest stream or the slow seep of a spring in limestone is part of this same story. Water always remembers the way down. Rivers are born from this persistence. They don't announce themselves with a single moment, like an earthquake or eruption. Instead, they emerge gently from snowmelt or springs, wandering across the land with no urgency. They choose the path of least resistance, but they never stop. And in their slow descent, they do more than shape the surface. They carve identity into the landscape. Valleys, canyons, floodplains, and deltas are all the work of rivers, drawing their designs over millennia. Unlike tectonic upheavals, which shatter and shift, rivers sculpt with care. They carry silt and stone, eroding some places, depositing in others. They create fertile lands and wash away ancient soil. Their channels twist and meander like living things. And when they flood, they don't just destroy, they renew. Entire civilizations have been built and sustained on the rhythms of rivers, relying on their quiet cycles of rise and retreat. The Nile, the Yangtze, the Mississippi, each one more than a waterway, more than a boundary. They are moving threads that stitch together human history with geological time. Beneath the surface, the sculpting continues unseen. Caves are born where underground rivers wind their way through limestone, dissolving mineral into passage. These rivers don't roar, they whisper. But over time, they hollow out vast chambers and winding tunnels, tracing paths through the dark like veins beneath the skin of the earth. Some of these subterranean rivers are ancient, flowing through rock older than any forest or mountain. Others are new, slowly branching into networks that may one day surface in canyons or springs. They connect to aquifers, seep into wells, shape the water we drink without ever revealing themselves. In Virginia's Appalachian Mountains, the New River cuts through stone that predates the dinosaurs. It's one of the oldest rivers on Earth, perhaps over 300 million years old, and despite its name, it has flowed longer than most mountain ranges have existed. It runs counter to the orientation of the ranges it cuts across, as if it came first and the land rose around it. That kind of longevity doesn't come from luck. It comes from consistency, from the unyielding movement of water across unimaginable spans of time. It comes from a river being allowed to follow its course, adjusting, deepening, settling in. What's remarkable is how little water it takes to begin this work. Not a flood, not a deluge, just a single drop, again and again. Even dripstone formations inside caves, stalactites and stalagmites, grow from nothing more than mineral-rich drops, falling slowly, accumulating crystal by crystal. Some have taken hundreds of thousands of years to reach their current shape, yet they still grow today, unnoticed in the silence, sculpted by patience. The presence of water and stone leaves more than physical marks. Sometimes, it changes the stone itself. Minerals dissolve and reform. Crystals grow in the quiet. Opals, with their dancing colors, form in pockets left behind by water that carried silica into empty space. Petrified wood, too, is the product of groundwater replacing organic material molecule by molecule, turning trunks into stone while preserving their grain. Even the most delicate structures, a leaf, a shell, a fish's skeleton, can be preserved if the water arrives with the right chemistry and the right timing. This quiet shaping isn't just geological. It teaches a kind of perspective that's difficult to hold in ordinary life. We often measure change in days, weeks, or years, but water invites us to think in centuries, in spans long enough that a drop can cut a valley, long enough that a river can outlast mountains, long enough that stone itself can be transformed from within. And when rivers dry up, as some do, their paths remain. Dry beds, twisted arroyos, ancient floodplains still etched into the land. Even without water, the memory lingers. The earth remembers where the rivers once flowed. Standing at the edge of a canyon or beside the slow bend of a creek, it's easy to feel like a witness to something vast but imperceptible. You know the water moves. You know the stone is changing, but you can't see it happen, not in real time. Yet if you were to come back in 1,000 years, the bend might be deeper. The cliff might have shifted. A new channel might have formed. And still, the water would be flowing. The earth is shaped not only by the violence of eruptions and quakes, but by the quiet conviction of water. Its artistry is slow, but unmatched. And it reminds us that transformation doesn't always arrive with sound and fury. Sometimes, it begins with a single drop, falling again and again until stone remembers how to bend. Glaciers do not roar as they move. They do not crash or thunder across the land. Instead, they shift with a patience so profound it becomes easy to mistake their silence for stillness. But these rivers of ice are never still. They move slowly, steadily, and with a force that rewrites the face of continents. Over years and centuries, they flow under their own weight, creeping downhill, pulling stone with them, carving the earth as they go. Their motion is almost invisible, yet their legacy is everywhere. Stand in a U-shaped valley, steep and smooth on either side, and you are standing inside the path of a glacier. It passed through long ago, dragging boulders and gravel in its frozen grasp, grinding mountain into silt, polishing the bedrock beneath like glass. Unlike rivers, which follow curves and channels, glaciers reshape the very contours of the land. They do not adapt to valleys, they make them. They scour and scoop and deepen, widening passages into vast amphitheaters of stone, silent proof of their former presence. At their greatest extent, glaciers have blanketed continents. During the last ice age, more than a third of Earth's land was covered by ice. It wasn't a uniform sheet, but a living, shifting body of cold that reached from the poles into forests and plains. Entire landscapes disappeared beneath the weight. Mountains stood like islands in a frozen sea, and beneath the surface, the crust of the earth bowed under the pressure. The sheer mass of ice, thousands of feet thick in places, pressed downward with such force that the solid rock beneath flexed and sank. The earth itself made room for the glacier's burden. But ice is temporary. It holds for a while, then recedes. And when glaciers melt, the land they once suppressed begins to rise. This process is slow, unfolding across centuries, but it continues even now. In parts of Canada, Scandinavia, and Siberia, the crust is rebounding upward, an echo of a vanished weight. Some places rise by centimeters each year, a reminder that memory is not just held in fossils and stone, but in the shape of the earth itself. The planet remembers the ice, and it stretches slowly back into the shape it held before. As glaciers advance, they carry more than cold. Embedded in their base are rocks of every size, from grains of sand to house-sized boulders, picked up along the way and frozen into their underside. These rocks become tools, grinding against the surface below, carving grooves and striations that point in the direction the ice once flowed. When the glacier melts, it leaves these rocks behind, scattered across fields, perched on hilltops, abandoned like strange, misplaced monuments. These erratics, as they're called, can be found hundreds of miles from their origins, carried across vast distances by nothing more than the slow drift of frozen time. And glaciers don't only shape the land, they shape the water too. They store it, lock it away in crystal silence, then release it in floods when they melt. Some of the world's largest lakes, including the Great Lakes of North America, were carved by glaciers and filled by their meltwater. These basins are not random. They are the scars of movement, carved deep and left behind, cradling water where once there was only ice. Even today, the melt from alpine glaciers feeds rivers in every direction, sustaining life far downstream in places that have never seen snow. Inside a glacier, the ice moves differently than we might expect. It doesn't crack and fall like shattered glass. It bends. Under immense pressure, ice behaves like a very slow liquid, deforming and flowing downhill even while it appears solid. The top layers, exposed to air and brittle, may break and fracture into deep crevasses, but below the surface, the ice folds and slips with eerie grace. This is not the motion of speed, but of inevitability. In Antarctica, some glaciers are still flowing today, inching toward the sea in an endless delivery of ancient ice. Some calve into towering icebergs, crashing into the ocean in moments of sudden drama. But that crash is the exception. The real power is in what you cannot hear, a glacier scraping its way forward beneath your feet, changing the world without a sound. And though they are often cast as cold and lifeless, glaciers are not without inhabitants. Microbial life exists within their icy interiors, surviving in tiny pockets of water and thin films along fractures. Some have been frozen for tens of thousands of years. Others are active even now, feeding on minerals in the dark, thriving without sunlight. The ice preserves them, carries them, buries them, and sometimes reveals them again when melt exposes ancient layers to the surface. There are even stories frozen in the glaciers themselves. Layers of snowfall compress over time, trapping air bubbles from past atmospheres. Scientists drill ice cores to read these layers like the rings of a tree, decoding ancient climates and long-forgotten seasons. Within that ice is carbon, dust, pollen, even remnants of volcanic ash from distant eruptions. Each layer is a year in the memory of the sky. To walk on a glacier is to walk across time. Beneath your boots is snow that fell before your country existed, before your language was born. Deeper still is snow that fell when mammoths walked the earth, when forests stretched across what are now frozen plains. Every crack, every echo underfoot, Every gust of wind across the surface reminds you that you are not on something dead, you are on something that moves. And when that glacier melts, the land will bear its imprint forever. Valleys will remain. Lakes will shimmer where there was once only pressure and silence. Forests will grow in soil left behind by the grinding ice. The memory of the glacier will not vanish. It will take on new shapes. The architects of continents do not work quickly, but they never stop. The earth is not gray. That's a trick of photographs, maps, and distant memory. In truth, the planet is a kaleidoscope, a living spectrum shaped not just by life, but by the minerals that pulse through its skin. Stone holds color with a kind of reverence, embedding it deep into its structure, layer by layer, reaction by reaction, long after the skies have changed and the oceans have shifted. These aren't surface decorations. These are ancient records, pigments of pressure and chemistry, written in codes of rust and fire, water and air. The reds that sweep across deserts like Mars come from iron, not from blood, though the metaphor is tempting, but from iron left exposed to air, reacting over time in a process not unlike the rusting of a nail. This oxidation gives sandstone its burnished blush, turning once neutral sediments into vast plains of ochre, crimson, and deep rust. The Sahara, the outback, the American Southwest, all wear the same badge of elemental decay. It's beautiful not because it is flawless, but because it tells a story. These colors are proof that this was once a world full of rain, of wind, of time, and of iron, quietly turning red as it aged beneath the sun. But not all earth is red. Some clays, nestled in the folds of forgotten hills, take on a soft, dusky blue. It isn't paint, it isn't dyed. This color emerges when certain minerals like glauconite or vivianite react with traces of water and the oxygen around them, transforming dull sediments into vibrant deposits. It's not an easy blue, not the artificial brightness of ink or sky, but a grounded one, the kind of blue that feels like silence, a blue that sinks into the skin of the world rather than sitting on top of it. This shade is rarer, more secretive, but when you find it in riverbanks, in exposed slopes, it feels like discovering something forgotten, something the earth meant to keep hidden just a little longer. Then there are the places where color doesn't just appear, it explodes. In China's Zhangye Dangxia landform, the Rainbow Mountains stretch like a painting brushed across the horizon. Here, the layers of sediment span tens of millions of years, each compressed line a different recipe of mineral and climate, laid down one after another like pages in a book no one ever meant to open. Reds, oranges, yellows, greens, even purples, and deep indigos rise and fall in waves, warped by tectonic uplift and carved by erosion. It's not a trick of light. The colors are real, baked into stone, exposed by wind and time. To look at these mountains is to see a timeline of the earth itself, displayed not in numbers or fossils, but in bands of color rising into the sky. And yet, some colors aren't visible until the light changes. There are minerals that glow under ultraviolet light, not because they absorb it and reflect it like ordinary pigments, but because of fluorescence, a deeper kind of interaction. In the dark, with the right wavelength, these stones ignite. Fluorite may glow blue or green, calcite, orange. Willemite pulses bright green like alien moss. These stones carry a hidden palette, invisible in daylight, waiting patiently in the dark to be revealed. It's a reminder that color is not always what it seems. Sometimes it sleeps, waiting for the right moment to bloom. Rocks trap color in ways that never fade. While paints chip and dyes wash out, the colors of stone are bound by molecular structure. Copper lends green to malachite. Sulfur gives yellow to realgar. Manganese, chromium, cobalt. Each element weaves into the crystal matrix, tinting it from within. This isn't surface deep. This is color as identity. And once forged, it endures. A piece of lapis lazuli dug from the mountains of Afghanistan can still carry the same rich blue it had 6,000 years ago when it was carved into jewelry or ground into pigment for the robes of pharaohs and the halos of saints. Stone doesn't forget. Even opals, the most elusive of gems, hold color in a way no other stone does. Their fire, their shimmer, comes not from pigment, but from structure. Microscopic spheres of silica, arranged in a precise grid, diffract light into its spectral components. It's a rainbow made not of dye, but of interference, a kaleidoscope born from the way light stumbles across a lattice too small to see. And yet, even that shimmer is stable. Hold an opal from 1,000 years ago, and it will still dance in the light, unchanged. There are places in the world where you can walk through color as if through weather. The painted hills of Oregon, the Badlands of South Dakota, the Technicolor sands of Utah. In each of these places, the layers underfoot were laid down when the world was different, when the air was thicker, the seas higher, the creatures stranger. The reds are ancient soils, the yellows, volcanic ash, the purples, traces of plant life long since turned to dust. What you're walking through isn't just a landscape, it's memory made visible. And perhaps that's what makes the colors of the earth so captivating. They aren't added, they aren't separate. They are born from the world itself, shaped by heat and pressure, by water and wind, by time and chemistry. They reflect the deep alchemy of geology, not just how things are made, but how they change. Every shade tells a story. A red might speak of oxygen-rich waters washing over iron-rich sediment. A green might hint at ancient swamps or copper veins curled in darkness. A blue might whisper of calm, cold seas long gone. Color, in this way, becomes something more than beauty. It becomes a language, a quiet one, layered and slow, spoken across epochs. The earth does not speak in words, but it does speak in stone. And stone, if you know how to look, is never silent. Beneath your feet, the world is not still. It may feel solid, quiet, reliable, a foundation to build upon and forget. But dig deeper, far deeper than any machine has ever reached, and you would find a world in motion, a world in heat, a world alive in ways we can barely comprehend. The deep earth is not a hollow shell, nor a frozen relic. It is a layered engine of rock and metal, pressure and temperature, constantly shifting beneath the crust that carries us. The crust itself is a whisper-thin rind compared to what lies below. Beneath it, the mantle begins a layer so vast it makes up most of the planet's volume. It is not molten, not in the way fire is molten, but instead flows like an impossibly slow liquid. It moves in convection currents, hot rock rising, cooler rock sinking, a churning cycle that takes millions of years to complete. This motion is what drives the continents, splits the seafloor, and feeds volcanoes. If the crust is a boat, the mantle is the slow-moving sea beneath it, too dense to see, too deep to touch, but powerful enough to shape the face of the earth. The mantle flows like honey left in a cold room, slow, stubborn, but not still. It carries heat from below, transporting energy from the heart of the planet outward. In some places, plumes of hotter mantle rise faster than the rest, creating hotspots that burn through the crust and form island chains like Hawaii. Elsewhere, cooler slabs of ancient crust sink back into the mantle at subduction zones, slowly recycling the surface into the deep. This cycle has been running since the Earth formed a planetary metabolism, unseen but essential. Far below the mantle lies the core, separated into two parts: the outer core, which is liquid metal, and the inner core, which is solid. Both are made mostly of iron and nickel, but the conditions are vastly different. The outer core churns with motion, generating the planet's magnetic field, a protective bubble that shields life from solar radiation and cosmic rays. Without it, Earth's atmosphere would be stripped away like Mars. Without it, compasses would spin aimlessly. The inner core is stranger still. Though it is hotter than the surface of the sun, it remains solid due to the crushing pressure. At more than 5,000 degrees Celsius, this sphere of metal sits like a glowing pearl at the center of the world, and it doesn't stay still. It spins not with the rest of the planet, but slightly out of sync. Scientists believe the inner core rotates at a different speed than the crust above, drifting ahead or lagging behind, depending on subtle changes in magnetic forces. It is, in a sense, a planet within a planet, turning quietly in the dark. Between the mantle and the core lies the DI layer, a mysterious boundary where seismic waves behave strangely, suggesting complex interactions between solid and molten materials. It may be here that some of the planet's oldest structures still survive, ancient slabs of crust, long subducted, hovering like ghosts in the deep. And within the mantle itself are features as dramatic as anything on the surface. Seismic data has revealed that there are mountains taller than Everest, buried deep beneath the crust, ridges and peaks hidden from view, but written into the way earthquake waves travel through the earth. These structures may be billions of years old, formed from the remains of ancient tectonic collisions, folded into the planet's underworld like crumpled pages in a book no one can read. Earthquakes don't only happen near the surface. Some begin hundreds of miles down in the transition zone of the mantle, or even deeper, where pressure is so intense that rocks behave in unfamiliar ways. These deep focus earthquakes are strange. They don't produce the same kind of surface rupture as shallow quakes, but their signals race across the globe, tapping on seismic instruments like distant drum beats. They suggest that the deep earth is not just a zone of heat and silence, but of sudden release, of tension and shift. The deeper you go, the stranger the rules become. Heat behaves differently. Pressure warps molecules. Minerals that would crumble at the surface form dense, exotic crystals that can only exist under intense conditions. Diamonds, for instance, form in the upper mantle, born in extremes and carried upward by volcanic pipes over millions of years. They are windows into a world we cannot otherwise touch. For all our machines and measurements, the deep earth remains largely unvisited. No drill has reached the mantle. No probe has touched the core. What we know comes from listening to the tremors of earthquakes, to the flow of heat, to the flickering compass needle responding to invisible fields. It's a science of echoes, shadows, and careful inference. Yet despite that distance, the deep earth affects everything on the surface. It is the furnace that powers plate tectonics, the generator of magnetic fields, the sculptor of continents, the source of volcanoes, and the birthplace of mountains. It is also a place of memory. Locked within the minerals that rise from the mantle are chemical records of Earth's earliest history. Some basalt flows contain traces of the planet's formation, hints of the chaos that followed the moon's birth. Iron-rich meteorites tell us what the core might be made of, matching the densities and compositions we suspect lie at the center of our world. Even though we can't go there, the Earth occasionally sends pieces of its deep self to the surface, gifts from a hidden realm. To imagine the Earth as a static ball of rock is to miss the miracle. Beneath your home, your city, your every step, is a world in motion, flowing, spinning, stretching, and compressing. It moves too slowly for us to feel, but its consequences are all around us. In the drifting of continents, in the shaking of quakes, in the rhythm of the poles, and the heartbeat of the magnetic field, the deep earth makes itself known, and though we may never see it, we live because it moves. Under crushing silence and the weight of time, beauty forms in places no eye will ever see. Miles beneath the surface, in darkness absolute, the earth folds in on itself, and in that unimaginable pressure, in that slow and ceaseless heat, something extraordinary begins to happen. The dull becomes brilliant, the ordinary, sublime, and what emerges, after millennia of quiet labor, are the stones we call precious. Not because they are rare, although many are, but because they are impossibly forged. born not in luxury but in violence, in collision, in compression, in the hidden tension between continents and time. Take emeralds. They don't grow just anywhere. They are forged in the seams where tectonic plates have collided, where ocean crust has thrust itself against continental rock, and minerals from entirely different worlds have been pressed together with perfect violence. Beryllium from the Earth's mantle meets chromium or vanadium in the crust, and the resulting green is like nothing else, a green not of surface leaves or sea, but of pressure, of deep time, of buried fire. These stones are ancient reunions of wandering elements, pushed into alignment by force alone. Some of the finest emeralds in the world were born in what is now Colombia, a place where long-dead seas once met rising mountains, and in each translucent shard, a history of collision sleeps. Rubies are different. Their red does not come from iron or fire, but from just the right pinch of chromium, trapped inside aluminum oxide. In the crystalline structure of corundum, this trace element causes a distortion in the way light is absorbed and reflected. The result is not just red, but a red so deep it seems lit from within. A red with weight, with temperature, with memory. Most rubies form in marble, another product of pressure, made when limestone is transformed under the heat and weight of metamorphism. To find a ruby is to find the fingerprint of ancient tectonic activity, of crustal deformation, of continental uplift. Each one is a fossil of pressure, a shard of the Earth's long interior breath. Opals are quieter, gentler in their formation. No explosions, no violent shifts, just water. Water seeping through rock, carrying with it dissolved silica, dripping into cracks and voids left by weathering and decay. Over time, sometimes thousands of years, sometimes less, these deposits build up in layers, forming the fragile, luminous structures we know as opals. Their color, their fire, comes not from pigment, but from the microscopic arrangement of silica spheres stacked in perfect symmetry. Light enters, bounces, refracts, and fragments into rainbows. This is not a mineral in the traditional sense, but a gel, a frozen slow-motion drip of mineral-rich time. Many opals still contain water traces of the fluid journey that made them. To hold one is to hold not just color, but process, a memory of dripping, of patience, of silent change. And there are gems rarer still, ones that form only in the furnace of dying worlds. Peridot, for instance, can arrive on Earth inside meteorites, pieces of the mantle of shattered asteroids delivered across space by impact. Some diamonds, too, especially those known as super-deep or ultra-high-pressure diamonds, are believed to form at depths far beyond the reach of conventional geology, perhaps even in the transition zone between Earth's upper and lower mantle, or as remnants from subducted slabs plunging into the abyss. These diamonds bear inclusions of minerals that should not exist near the surface, trapped snapshots of an underworld we cannot visit. And yet, they find their way to us, lifted by volcanic eruptions, carried in pipes of kimberlite like messages sent from a darker, denser realm. Gems are not the result of peace. They are born of change, relentless, crushing, transformative change. They require instability, the shifting of plates, the rising of mountains, the evaporation of seas. Even the gentlest ones, like amber, formed from the hardened resin of ancient trees, are products of death and fossilization, of forest ecosystems collapsing and leaving behind their shining ghosts. Every gem is a story of upheaval paused in crystalline form, and they endure. While metal rusts and wood rots, these stones remain, polished, cut, displayed, yes, but also misunderstood. Their worth is not in their shimmer, but in their survival, in their geometry, written under pressure, in their chemistry, bound by time. They are beautiful not despite their origins, but because of them, because they carry inside them the tension of creation, the slow collision of earth and element, of fluid and fracture, of heat and silence. Sometimes, when you hold a gem to the light, it seems to glow from within. That glow isn't just a trick of optics. It's the deep breath of the earth itself, caught and held, a kind of stored thunder, crystallized, a whisper from below. We adorn ourselves with these fragments not just for their beauty, but for what they represent: permanence, transformation, resilience. But perhaps we forget that they come not from the heavens, but from the most secret parts of the earth, from the boundaries of plates, from the depths of ancient seas, from the long, patient pressure of time. To wear a gem is to wear a map of a world in motion, and to see one clearly is to see, if only for a moment, the invisible labor of the planet that made it. Beneath the restless surface of the ocean lies a world few have seen, but one that stretches for tens of thousands of miles, a world not of silence, but of murmurs, pressure, and fire. The seafloor, though hidden beneath miles of dark water, is no less dramatic than the landscapes we walk upon. In fact, it may be more so, because beneath the waves, the earth is building itself anew every day. The mid-Atlantic ridge, for instance, is the longest mountain range on the planet, longer than the Andes, Rockies, and Himalayas combined. But you won't find it in a travel brochure or on a postcard. It runs, like a seam across the ocean floor, from the Arctic all the way to the southern tip of Africa, a massive rift where tectonic plates slowly pull apart and magma rises to form new crust. Here, in the absolute dark, mountains are born in silence. Lava spills from deep fissures, cools instantly in the frigid seawater, and becomes stone, not over eons, but within moments. An entire ridge system, thousands of miles long, being built beneath our feet, hidden by nothing but water. The seafloor is not old, at least, not in the way continents are. While parts of Earth's land surface are billions of years old, most of the ocean floor is less than 200 million, and some of it is new, just minutes old. Because the ocean crust is constantly recycled, born at mid-ocean ridges, and pushed outward over time until it sinks back into the mantle at deep ocean trenches. It is the conveyor belt of the planet, the place where the Earth quietly remakes itself in a slow, steady rhythm. And it is not still. Even now, somewhere in the depths, an underwater volcano is erupting. It happens with no warning, no flash of light, no smoke rising into the sky. Instead, lava pours into the black, icy water, hardening instantly into pillow-shaped stones. Bubbles of gas hiss out, minerals crystallize on contact, and sometimes life follows close behind. For in this darkness, new worlds are formed not just of rock, but of biology. Hydrothermal vents cracks in the seafloor, where superheated water, rich in dissolved minerals, bursts forth, are unlike anything else on Earth. The water, heated by magma below, can reach temperatures of over 400 degrees Celsius, and yet, around these vents, life thrives. Entire ecosystems, built not on sunlight, but on chemistry. Bacteria that eat sulfur, worms that glow, shrimp with no eyes. These are not just oddities. They are reminders that life finds a way in places we once thought impossible. The minerals that form around these vents are equally strange. Some are found nowhere else. Bizarre combinations of metal and crystal that grow in shimmering towers called black smokers, named for the clouds of dark mineral-rich water they spew. These vents can build chimneys tens of feet tall, sculpted from dissolved rock and born in a world of pressure and heat. Some of them grow faster than corals, faster than trees. Structures of stone, rising in the dark like castles on a seafloor no human will ever walk. It is a place of extremes. Temperatures swing wildly. Pressures rise so high they would crush a submarine like a soda can. And yet, the stone here records every moment, every shift of the plates, every eruption, every intrusion of magma. The crust below the oceans tells a story written in basalt and pillow lava, in rift zones and fracture lines. We read it not with our eyes, but with sonar, with sensors, with seismic echoes that bounce through the deep. The deep sea is not quiet. It groans with the tension of spreading ridges. It pulses with the beat of underwater quakes. It rumbles with eruptions that never break the surface. Sound travels far in water, and sometimes these movements can be heard thousands of miles away. A murmur here, a tremor there, the whisper of rock being born. Some parts of the ocean floor are so untouched, they remain as pristine as the day they formed. Others are littered with manganese nodules, strange, rounded rocks that grow slowly over millions of years, like barnacles made of metal. No one knows exactly how they form, only that they do, quietly, in the stillness of the abyssal plains. Some nodules contain rare earth elements, making them potential treasure troves of future technology, but to harvest them would be to disturb a world that has never known machines. What the ocean hides in its depths is not just unfamiliar geology, but forgotten time. It conceals ancient ridges, hidden volcanoes, and valleys deeper than Everest is tall. It holds scars from asteroid impacts, trenches that pierce deep into the mantle, and faults that slide past one another without a sound. It is a record of Earth in motion, sealed beneath a pressure no sunlight can reach. And yet, it is fragile. One shift in temperature, one shift in chemistry, and entire habitats can disappear. The stone remembers, but it also changes. The seafloor, though vast, is not immune to our actions. Sediments trap the evidence of runoff, of plastics, of change. Even here, in a realm we do not live in, our presence is felt. But still, the work goes on. The mountains grow, the vents breathe. The earth rebuilds itself in silence, one lava flow at a time. The ocean floor is not the basement of the world. It is its workshop, its cradle, its mirror, buried beneath waves that never sleep. And when we imagine the earth as whole, not just its surface, but its depths, we begin to see that the planet is not just alive above, but alive below, in folds of basalt, in columns of smoke, in ridges no eye will ever see. A second earth, hidden in plain sight, building itself anew with every breath. The desert is still. The air barely shifts. A breeze passes like a thought, weightless and brief. And yet, on the cracked floor of an ancient lakebed, something strange happens. A rock, ordinary and sun-bleached, begins to move. Not quickly, not noticeably, but over days and weeks, it leaves behind a trail, a long, winding path scratched into the hardened clay, as if it were tracing its own story across the surface of the earth. No hands touch it, no animals push it, just stone, gliding in silence. These are the sailing stones of racetrack playa, and they move without legs, without engines, without answers. For decades, no one could quite explain them. Some thought it was the wind, though how wind could move rocks that weigh hundreds of pounds seemed implausible. Others wondered if the earth itself was nudging them, pulling them slowly as it exhaled and contracted. But the truth turned out to be stranger still. It takes just the right conditions, a shallow layer of rain, a sudden freeze, a thin sheet of ice forming beneath and around each stone. Then, a breeze, light but steady, pushes the stones across the slick, icy mud, leaving behind their signature paths. The movement is glacial, hypnotic, and vanishingly rare. But it happens. Rocks move on their own, reshaped not by violence, but by an invisible choreography of elements. The earth has its rhythms. We often forget that. We think of it as still, except when it rumbles or shakes. But the planet has a pulse, not one of blood, but of resonance. A kind of background hum, so low and subtle that it goes unnoticed by most of life. It is called the Schumann resonance, and it vibrates through the atmosphere between the surface of the earth and the boundary of space, trapped in a shell of energy, like sound in a drum. It beats at around 7.83 hertz, a frequency so low you cannot hear it. Yet it's there, constant, like the deepest sigh of the planet itself. Some have called it Earth's heartbeat. It shifts with lightning storms, with solar winds, with the breathing of the ionosphere, and though it is invisible, some claim we may be attuned to it, that our own biology echoes its rhythm. The earth is filled with oddities, like these small wonders that don't announce themselves, that don't make headlines or erupt with force, but they're there, etched into the landscape in quiet, breathtaking detail. Consider fulgurites. When lightning strikes sand, it doesn't simply scorch it, it fuses it. The immense heat, hotter than the surface of the sun, melts grains of silica in an instant, and the result is a hollow, branching tube of glass, fragile, twisting, and pale, like roots made of stone. These glass sculptures trace the exact path of the lightning bolt underground, freezing a moment of immense power into a delicate, crystalline fingerprint. They're sometimes called fossilized lightning, and that's not far from the truth. You can hold one in your hand and know that, in that very spot, the sky once reached down and touched the earth. And then there are the quietest fossils of all, the ones not made of bone or shell, but of rain. Fossilized raindrops, captured in stone from nearly 3 billion years ago. Imagine it, a light rain falling on soft volcanic ash, long before animals, before plants, even before the atmosphere was rich in oxygen. Just water, falling through ancient air, pocking the surface with tiny dimples. Then, a covering of sediment, sealing the pattern. Then time, unfathomable time. And now, in a slab of stone pulled from the depths of the earth, those gentle impressions remain. We can measure their depth, their spacing, and from them infer how dense the atmosphere was, how fast the drops were falling. The rain that left these marks is long gone, but the stone remembers. Geology is filled with such secrets. The quiet kind, the ones that reveal themselves only when you ask the right question. Why does this stone curve like a wave? Why does this cliff shimmer in a certain light? Why do these mountains lean instead of stand? And more often than not, the answer lies not in what's visible, but in time, in pressure, in chemistry, in accidents that turned into patterns. Some stones hum when struck, ringing with clear tones like musical instruments. Others glow under ultraviolet light, their crystals storing and releasing energy in strange and beautiful ways. In certain caves, you can find selenite crystals that have grown over millennia into walls of pure, translucent geometry. In others, stone drips slowly into the shapes of animals, of waves, of frozen storms. All of this, the moving rocks, the singing stones, the glowing caves, is geology. But not the kind found only in textbooks. This is the kind you feel in your bones when you stand on a cliff and sense the weight of the planet beneath you. When you run your fingers over an ancient fossil and imagine the silence it came from. When you realize that the ground isn't just where you stand, it's a record, a language, a memory. And the more we look, the stranger it gets. There are stones that form only in the presence of living bacteria, blurring the line between mineral and organism. There are pebbles that whisper of ancient riverbeds, long vanished. There are canyons shaped not by rivers, but by salt, by collapse, by time folding in on itself. The earth is filled with riddles like these, left behind by processes we are only beginning to understand. Geology is often thought of as slow, but that's only because we measure it with human clocks. In the scale of stone, every breeze, every drop, every bolt of lightning leaves a mark, and the earth, for all its mass, is a sensitive thing. It responds, it records, it changes, sometimes loudly, but more often it whispers. The earth has died many times, not in a way that ends everything, but in waves, pulses of disappearance that sweep across oceans, forests, and skies. At least 5 times in its long memory, life has collapsed in on itself, undone by forces so vast they seem to come from beyond the world itself. And each time, the planet has emerged changed, reshaped not just in the lives it holds, but in the stone beneath our feet. Mass extinction sounds like an event, A single blow, sudden and final, but often it is a slow unraveling, a cascade of endings triggered by something seemingly distant, a shift in climate, a burst of volcanic fire, the impact of a visitor from space. The Ordovician extinction, over 440 million years ago, was not caused by heat, but by cold. A sudden ice age dropped sea levels, and with it, much of the marine life that had flourished in shallow oceans simply vanished. The world froze, and life blinked out beneath the ice. Then came the Devonian, where ancient seas turned toxic. Plants, newly thriving on land, sent roots deep into stone, pulling nutrients into rivers. Those rivers flowed into oceans, and in their wake bloomed algae that sucked the oxygen from the water. Fish suffocated in place. Coral reefs died back for tens of millions of years. The planet wasn't trying to destroy life. It was just evolving. And evolution doesn't always come gently. The Permian extinction is still called the Great Dying. It wiped out more than 90% of marine species and over 2/3 of life on land. Some scientists believe it was caused by volcanic eruptions in what is now Siberia eruptions that lasted for hundreds of thousands of years. They poured out lava, yes, but also carbon dioxide and methane, warming the planet so rapidly that oceans turned acidic and stagnant. Forests burned, reefs collapsed. The sky itself may have turned a strange shade, lit by soot and fire. And yet, the earth did not stop. It paused, it gasped, and then it built again. In the silence that followed, new creatures emerged, small, strange, and resilient. Among them were the ancestors of dinosaurs, which would go on to dominate the planet until another extinction, this time sparked by a rock from space, ended their reign. The Chicxulub impact 66 million years ago sent a shockwave around the planet. It ignited forests, threw dust into the sky, and dimmed the sun for years. Photosynthesis stopped. Food chains collapsed. What had taken millions of years to build unraveled in a geological instant. But in the shadow of that loss, mammals rose. Birds, the living echoes of dinosaurs, found new skies. Flowers spread across continents, and the continents themselves, ever shifting, turned and collided, lifting new mountain ranges, breaking apart old supercontinents, and recycling the very surface of the earth. Because even the land is not permanent. Continents drift, riding on tectonic plates that move as slowly as fingernails grow. When plates collide, mountains rise. When one slips beneath another, it is drawn into the mantle, where it melts and becomes new again. This process, called subduction, is how the earth cleans its slate. Ocean floors disappear into trenches. Volcanic arcs rise above the subduction zones, built from melted stone. What was once surface becomes magma. What was magma becomes crust. It is a cycle that erases and rebuilds not quickly but inevitably. In some cases, it's the volcanoes themselves that both destroy and renew. While we often think of eruptions as harbingers of fire and ash, they also fertilize. Volcanic soils are some of the richest on Earth, filled with minerals that plants crave. After the smoke clears, life returns, stronger than before. This happened in Iceland, a country born from fire, where new land continues to emerge, and it has happened across the Ring of Fire, where eruptions wipe the slate clean, only to feed the next wave of forests. Not all volcanic activity warms the planet. Sometimes, the ash they release blocks sunlight, cooling the world dramatically. The eruption of Mount Tambora in 1815 led to the year without a summer, with frost in June, failed crops, and famine across continents. A single eruption changed the climate for years, and in Earth's deeper past, far larger eruptions may have done the same, shielding the surface from sunlight long enough to trigger extinctions. But for each loss, there is transformation. After each collapse, the survivors adapt. Evolution accelerates in the gaps left behind. Ecosystems reorganize. new niches open. The timeline of Earth is not a straight road, but a loop, an endless cycle of building, breaking, and rebuilding. Life is not separate from geology. It is sculpted by it. Even now, deep beneath the continents, subducted slabs of ancient ocean crust continue their slow descent into the mantle. Their journey can take hundreds of millions of years, and when they melt, they may one day rise again as lava in a place yet unborn. The continents. We know the familiar outlines of Africa, Asia, the Americas, are temporary arrangements. They have merged before into a single mass called Pangea, and they will merge again. The Atlantic Ocean is growing, but not forever. One day, it may close. Mountains will rise where now there is sea, and seas will flood what is now land. We often imagine extinction as the end, but on this planet, it has always been the beginning of something new, a painful, beautiful, chaotic rebalancing. One species falls, another emerges. One environment collapses, another unfolds in its place. The stone remembers each one. In its layers are traces of forests, deserts, oceans, fires, and silence, a record of every ending and every return. The earth is not static. It breathes in epochs. It thinks in tectonics. It survives in cycles. And if you listen closely, in the rustle of leaves, in the shape of a mountain, in the fossils buried deep beneath your feet, you can hear the rhythm, not of permanence, but of change. The ground beneath you is not still. Though it may feel solid, silent, unchanging, it is anything but. Beneath the soles of your feet, continents drift on seas of molten rock. Cracks open and close along invisible seams. Mountains rise, crumble, and rise again. Every tremor, every fold of stone, every whisper from the deep is part of a living system, ancient, restless, and very much alive. Earth is not a finished world. It is not a completed sculpture, but a work in perpetual progress. Even now, as you listen, an island is being born somewhere beneath the ocean. Pressure builds along an unseen fault line. Lava rises from a rift, meets cold seawater, and cools into stone. It piles upon itself, layer after layer, until one day it breaches the surface steaming, crackling, raw. A newborn landmass emerging from the sea, wrapped in mist, unclaimed by anything but the elements. It may be no larger than a house at first, but in geologic time, it could grow into a continent. These new islands aren't merely curiosities, they are reminders. Reminders that our planet is still in the act of becoming. The crust we live on, the hard shell we build cities on, plant forests in, and carve tunnels through is thin. A brittle skin over a world that churns with heat and pressure. Beneath the crust lies the mantle, a vast layer of rock that moves like thick honey. It flows slowly, too slowly for us to feel in a single lifetime, but it moves nonetheless. And as it does, it carries heat outward from the core, driving the plates above like ice flows on a warming sea. These motions are not random. They are the breath of the earth, a breath that expands and contracts in cycles lasting millions of years. The crust itself pulses, rising and falling with the weight of glaciers, with the shifting of tides, with the tug of the moon. In some places, it is pulled apart, creating rift valleys and spreading centers. In others, it is compressed, folding into mountain ranges or plunging into the mantle through subduction. Even when we are still, the world is not. In Iceland, the land splits a little wider every year, as the North American and Eurasian plates drift apart. In the Pacific, the ring of fire circles the ocean with volcanic arcs and earthquake zones, scars of a restless margin. In the deep, lightless trenches, slabs of ocean floor disappear into the earth, dragging with them sediment, crust, and memory. And from this destruction, new land is made. Volcanoes rise. Arcs of rock form bridges between plates. Even the mountains of the Andes and the Himalayas owe their height to this constant reshuffling. Every pebble tells this story. Every grain of sand, shaped by wind or water, once belonged to a larger whole. A mountain, a cliff, a shoreline, long vanished. Rocks are not just stone, they are time made solid. They are witnesses to the movements of Earth's skeleton carried by rivers, blown by storms, worn by the touch of time. Pick up a single stone, and you're holding the history of a landscape that no longer exists. Even the core, the deepest part of the Earth, plays its part in this quiet orchestration. The inner core, a solid sphere of iron and nickel, spins at a different speed than the crust above. Around it, the liquid outer core swirls in currents, driven by heat and motion, creating our magnetic field. This invisible shield protects life from solar wind and cosmic radiation, and yet, it too is part of the same slow, rhythmic movement that drives volcanoes, plates, and tides. Sometimes, we feel this movement directly, in the sudden jolt of an earthquake, in the hiss of a geyser, in the slow creep of land after heavy rain. But more often, it moves beneath our awareness, slow, deep, patient, like the quiet shifting of breath in sleep. It is easy to forget that we are not above this motion, but part of it. The rock beneath you is not dead. It is not static. It pulses with energy, stores memory, and responds to the forces around it. Some stones hum with piezoelectric tension. Others record the direction of ancient magnetic fields. Some glow under ultraviolet light, holding within them the elements of starlight. Each one, in its own way, is alive with the processes that built and continue to shape this planet. The entire Earth is a living system, not in the way a creature breathes or bleeds, but in the way it transforms. The atmosphere, the oceans, the tectonic plates, all parts of an intricate balance, shifting slightly, always adjusting. And you, standing on it, are not separate. You are not an observer. You are one more layer on the surface of this long unfolding story. Human history is short, but it is written in stone. Our oldest homes were carved into cliffs. Our monuments stand as rearranged rock. We draw lines on maps that the continents ignore. We build cities on faults, plant crops in volcanic soil, and dig into the crust for the remnants of ancient fire. Our tools, our temples, our bones, all will one day return to stone. To live on Earth is to live on something that moves, something that grows, that recycles, that begins again and again. You may not feel it, but beneath your feet, the ground is alive with the memory of collisions and creation. A planet that was once molten and bare, now teeming with color, complexity, and change. And in the quiet moments, when the wind is still and the stars are out, if you listen carefully, you might hear it, the soft, ancient breath of the world turning beneath you. Not loud, not hurried, just steady, enduring, alive.